Hello and welcome to my video today. Today I'm going to talk about Pascal's Triangle, which is a very famous and useful triangle in mathematics, and it helps us to solve a lot of problems faster. Basically a triangle of numbers. It can go on forever and ever and ever, but I've only done 6 rows here. And basically you start at the top with the number 1, and then underneath you write 2 1s. And then after that, you've got 1, 2, 1. So where did the numbers come from? Well, the 1s are pretty obvious. They just go on the outside edges. The numbers in between, however, there's a set method of finding those. So what you do is you take the 2 numbers above it, add them together, and that's the number below it. So you've got 2 1s on the second row. You add those together to get 2. So 2 goes underneath those. And then on the third row, you've got 1, 2, 1. So you add the first 2 together, 1 and 2, to get 3, and you put that underneath. You add the next 2 together, 2 and 1, and you get 3 again, and that goes underneath. And you keep going like that. Or if you look at the bottom row, you've got 2 10s. Where did the 10s come from? Well, one 10 comes from the 2 numbers above it, which is 4 plus 6. The other 10 comes from 6 plus 4. Now, if you look at the diagonals, you'll notice that first diagonal is all 1s. The second diagonal is 1, 2, 3, 4, 5, and that goes on forever. That's just the natural numbers. The third diagonal starts 1, 3, 6, 10. Those are actually known as triangular numbers. We'll look at that in a moment. And so on and so on. And there's other properties in the triangle. So one of the most useful features of the triangle is it allows you to find what are called the binomial coefficients. So each row is actually binomial coefficients. So 1, 1, the second row there, that would be the binomial coefficients for a plus b to the power of 1. So a plus b all to the power of 1 is just a plus b. The coefficient of a is 1, the coefficient of b is 1. If you had a plus b squared, it would be a squared plus 2ab plus b squared. The coefficient of a squared is 1, coefficient of ab is 2, coefficient of b squared is 1. So that corresponds to 1, 2, 1. And if you had a plus b all cubed, it would be 1 times a cubed plus 3 times a squared times b plus 3 times a times b squared plus 1 times b cubed. So I've just read that from 1331. So it's very useful, very handy. Another thing we can do is we can compute n choose k, or any n or k. So n is the row and k is the distance from the left. Example, 4 choose 2 is 6. And we can do that on the triangle. So let's go and have a look at the triangle again. 4 choose 2. So 4 choose 2. So if you don't count the one at the top and count down to the 4th row, so you have this row here, 1, 4, 6, 4, 1. That's the one we're looking at. It's the one that contains the number 4. So to get 4 choose 2, we go for that row that contains the number 4. And then choose 2, so the 2 corresponds to the distance from the left. You count 2 from the left diagonal. So you've got 1 is 0, obviously, and then 4 is the first one, and then 6 is the second one. So the answer is 6. And you can do another quick example in your head. If I asked you, what is 5 choose 4? Well, you go to the row that contains 5. So that's 1, 5, 10, 10, 5, 1. And choose 4. So where does the 4 go? So the 4 you count from the left. Don't count the first row. So 0, 1, 2, 3, 4. Count from the left, so you have 1 is 0, 5 is 1, 10 is 2, 10 is 3, 5 is 4. So it's the 5 on the right. So 5 choose 4 is 5. And another final quick example. If I asked you to compute 2 choose 2, well, we know straight away the answer is 1 because n choose n is 1. But let's do it on Pascal's triangle. So we go to the row which is 1, 2, 1 because that's the one with the 2 in it. And then we count 2 from the left. So 1 is obviously 0, 2 is 1, and 1 is 2. So there's your answer. It's the one on the right. 1, 2, 1. It's the final one on the right of the row 1, 2, 1. So 2 choose 2 is 1. And then if you look at that, you go down to the next one. It's pretty obvious. 3 choose 3 is 1. 4 choose 4 is 1. Just by reading them off Pascal's Triangle. Even if you didn't know the factorial formula for n choose n, you could just read them off Pascal's Triangle. So the first diagonal is all 1s, as we just saw. Second diagonal is the natural numbers, which we discussed a minute ago. Third diagonal is the triangular numbers. But let me discuss the triangular numbers. What does that mean? Well, think of the little triangle at the top. 1, 1, 1. So it looks like a little triangle with 1 and then 2 underneath. And then you can keep going down, so you could make a bigger triangle, 1 and then 2 1s underneath, and then 1, 2, 1. So that looks like a wee triangle, 1, 2, and 3. Now, if you can think of a snooker table with snooker balls, so that would be like 1 snooker ball, and then 2 underneath, and then 3 underneath that, and then 4 underneath that, 5 underneath that, 6 underneath that. So you've got a big triangle there, and then within that you've got all these little triangles. So the triangular numbers, what they are, they're basically, you're adding up the number of balls, say on a snooker table, in the triangle, starting from the top and work your way right to the bottom. So you'd have 1, and then 2 on the next, 3 on the next, 4 on the next, so you'd have 1 plus 2. So for that first little triangle, 1, 1, 1, so that would be 1 plus 2, which is 3. Well, the first one is also a little triangle in its own right, so that would just be 1. That's a trivial one. It's hard to see from one number. And then the next one after the 1, 2, 3 would be 1, 2, and then 3. Add them together, you get 6. And then the next one would be 1, 2, 3, 4. Add them together, you get 10. You'd have 1, 3, 6, 10. So that's that third diagonal. And then the next one would be what you would see on a snooker table, 1, and then 2, and then 3, and then 4, and then 5. Add them together, you get 15. There are 15 red balls on a snooker table. So that's the idea behind triangular numbers. So I've outlined a few of the cool properties of Pascal's triangle. One other little thing before I go. In terms of the n choose k's, there's a formula which I have covered in another video where you can add certain numbers together, and then you can come up with new formulas involving factorials and combinatorics like n choose k plus 1, etc. So imagine I had, for example, 4 choose 1. So 4 choose 1 would be 4, and then I had 4 choose 2, which would be 6. So imagine I added them together. So 4 choose 1 plus 4 choose 2 is 4 plus 6, which is 10, and that's the 10 underneath. Now what is that in terms of n choose k? Well, 4 choose 1 is 4, 4 choose 2 is 6, and then the 10 underneath, what does that represent? Well, that's 5 choose 2. Why is it 5 choose 2? It's 5 choose 2 because it's on the row that contains 5, so you take the number in the second diagonal, 1, 2, 3, 4, 5, and then, as I said earlier, you count from the left. So 1, 5, 10. So 10 is 2 from the left diagonal. So that 10, if you write it in n choose k form, would be 5 choose 2. The 10 to the right of that, the second 10, would be 5 choose 3. So what that means is, that means that 4 choose 1 plus 4 choose 2 is equal to 5 choose 2. Or in n choose k terminology, n choose k plus n choose k plus 1 is equal to n plus 1 choose k plus 1. And I've just demonstrated why that formula works using Pascal's triangle. I had proved it in another video, but now I've proved it using this beautiful triangle. So that's a few properties, and I hope you enjoyed that video. there are many, many others that you'll meet on your mathematical journey. So that concludes the video. Have fun with Pascal's Triangle. Thanks for watching. Please subscribe and I'll see you on the next video.